All right, pre-AP 11. Let's chat and take a look at lesson 1, factor on our factoring and radicals unit. So when we're looking at this, right, factoring and radicals, we're going to take something we call a quadratic, right? So quadratic looks like ax squared plus bx plus c, and it has a pattern of having a square, single linear factor, so that this is to the 1, and it has really a hidden x to the 0 here. So it starts with a square, a single factor, and then no factor, right? So this is going to be our constant at the end. But our goal for this is to make it into some form where it's x plus or minus some factor p x minus plus or minus q, right? We're trying to break it apart into two linear factors, and we're going to see lots of reasons and applications for this later on as we go along. But really, like if we were going to take like a base case here, so a and b are going to stand in for just like arbitrary numbers, where x is our variable. And we would just FOIL this out normally, and we get something like x squared plus abx, 2abx, excuse me. No, it'd be a plus bx. I'm not foiling fair. Actually, let's go back and let's just FOIL it. Okay, let's just FOIL it. Let's just do the whole thing. I'm not going to skip a step. So this is going to be x squared plus ax, I did bx first, plus ax, the order is not really going to matter, plus ab. And so what happens if I have those two factors, I'm going to get x squared, and I'm going to actually say this is a plus b, and I took out a GCF out of x plus ab. And so our factoring is mostly just going to follow this pattern, right? And what we're going to use to make this work is this: if I had this, it's going to be x, x, a, b, and the end multiplies and the beginning. So these two columns, they multiply together, right? So that multiplies, get AB on the ends, right there, and x squared on the end. And the diagonals on the inside, they multiply, then add. So I'd get XA plus XB, and then they add together, but I could take a GCF out in that case. So those are kind of like our general format for a quadratic. So when we're doing this, let's take a look at an example. So let's look at example 1. The first thing that we're going to see here, let's just try x squared plus 7x plus 12. So if it's going to fit our original format, we need two numbers, a plus b, that equals 7, and two numbers a times b that equal 12. So we're just going to have to pick from the factors of 12 to make it work. So I could do 1 and 12. No, that doesn't work. 2 and 6. Well, if we add those together, 1 and 12 add to 13. That won't work. 2 and 6 add to 8. 3 and 4 add to 7. So it looks like this is going to be x, 3, and 4. So what's happening is this is going to be x plus 3, x plus 4 are our factors. So we've taken a quadratic that has a higher power, x squared, and made it a lower power now, right? So we've kind of gone by the definition, and we can make that work as well too, right? Use the definition to help us out here. So what if we don't always have just pure addition? Well, let's look at one with x squared minus 7x plus 6. So if we're doing that, then we have to make it multiply to 6 and add to negative 7. Well, let's just do the box method because that helps us. So that has to be x and x, and it has to multiply to positive 6 and adds to some negative number. So both of these need to be negative. Negative times a negative is positive, right? So when I'm looking at that, that's here coming from that. And I need to get to negative 7. So if I do 1 and 6, well, 1 and 6 adds to 7. And I can double check 3 and 2, that adds to 5. So that's not going to work. So it's going to be 6 and 1. And so my factors are going to be x minus 6, x minus 1. And that's factored. So this is going to be x squared minus 6x plus 6. And that's the same as we have right there. Perfect. So we're still meeting the rules for what our quadratics, what our trinomials look like when we factor them. Different ones as well too. Maybe we have a negative number on the end. So if we have a negative number on the end, like x squared plus 3x minus 10, what that means for us is that one of these terms has to be positive and one has to be negative, right? In order to multiply 10, so one has to be positive, one has to negative 10, that is. One has to be positive, one has to be negative. Now, the clue here that which one is going to be positive, which is going to be negative, is that the bigger number has to be positive because the resultant addition subtraction is positive, right? So it only works if the bigger number were positive for this middle term to be positive. So 10 is 10 and 1 and is some combination. So I can only get 10 and 1. It's going to be plus or minus 9, so that's not going to work. And if I have 5 and 2, well, I'll get plus or minus 3. So it looks like plus or minus 3 is my deal, but since it's plus 3, I have to have positive 5, negative 2. So my two factors are going to be x plus 5, x minus 2, right? So I can work out over here which one is going to work out for us here. All right, let's try another one. Keep moving along. Let's get lots of examples out here. X squared plus 8 minus 6x. So this isn't in order. If it's not in order, rewrite it, right? So if we're not in order, let's just rewrite it to get it into order, and we can see the pattern from there. So this is going to be x squared minus 6x plus 8. Oh, here I see the pattern. Again, I need to multiply to positive 8, add to negative 6. Well, if I have that negative positive combination, I know both of these are negative. This has to be x, that has to be x. And I have 8 and 1. Well, that's going to be 9. That's not going to work. So it has to be 4 and 2, which is going to be negative 4 plus negative 2 make negative 6. So there we go. So I'm going to get x minus 4, x minus 2. And there we are. So that's my factoring. That's the answer for that one, right? So again, the idea, the highlight to take away there is make sure that you have it in the correct order. All right, let's throw a new wrinkle in there. So if we have x squared, actually, no, let's not worry about, let's actually throw this wrinkle in there. Minus 2x plus 4. Let's do this wrinkle first. Well, let's use the box method again. Let's make a box here, see what can be done. X. Well, it has to be two negatives that multiply to positive 4 and add to negative 2. Well, the only things that are going to work are 4 and 1, 2 and 2, and they both have to be negative, right? So I have to have negative 4 plus negative 1. I have to try that, and I have to try negative 2 plus negative 2. Those are the only things that'll work. Well, negative 4 plus negative 1, that's negative 5. Negative 2 plus negative 2 is negative 4. So neither of these work, so that doesn't work. So this one is unfactorable, no solution. So we're going to actually see unfactorable later as to why things are unfactorable. So this is unfactorable, no solution. So we'll just leave it there. Unfactorable, no solution. Good. Next up, number 6. Let's try this out. Next up. So let's factor x squared. And what I'm doing is I'm just kind of going through the examples in your workbook. You can follow along in your workbook just as well and take a look at and follow along in the examples and see the terminology that the workbook uses. They're very mathematically precise so that you can see what's going on there too. So I'm going to do x squared plus 4xy minus 21y squared. What we do know is that this is going to be x and x, and I know that multiplication happens on the end, and I have a single y in the middle, so I do know that I'm going to have y and y here. I'm just going to think of that as a constant, and I get to that y squared from multiplication because I have a single y in the middle. I know that the ends multiply, so I'm totally okay with this. That wrinkle doesn't bug me too much. What I do need to take care of is I need to get to negative 21 and add to positive 4. Well, from the other one, I know that this is going to have to be 7 and 3. 7 minus 3 is 4, or 3 minus 7 is negative 4, but I want to reach positive 4. So 7 has to be the bigger number, and 3 has to be the negative number. The bigger number 7 has to be positive, and the smaller number 3 has to be negative, since this middle term here is positive altogether. So I'm going to get x plus 7y I'm going to get x minus 3y, and that's my factoring there. Okay, a few more, and that's where we'll leave it. Number 7. So we look at this example here, and I'm going to look at 5x squared plus 35x plus 60. And if I take out this common factor here, right? I kind of jumped the gun a little bit. So I do have a common factor. I want to take care of something. Each of these can be divided by 5. So if each term, right, each thing separated by addition or subtraction, so they're called terms, each thing that's separated, if each term has the same factor that can be divided by the same factor, that's our greatest common factor, right? So we're going to take 5 out, and now this becomes x squared plus 7x plus 12. Hey, and that's the same as the first problem we had. I'm not going to resolve it for us. It's just going to be x plus 4, x plus 3. And some of this is like, why are we doing so much of it? Well, we're going to see the applications and use for it later. We're just going to master it right now. And when we get to the applications and use, it's going to be very clear why we did that. We can do a couple things here with this new example. We're going to introduce a negative in a place we haven't seen before. So we have negative x squared plus 5x plus 6. And what I'm going to do is we can do it two ways. You could do negative x, and x, and it has to multiply positive 6, 3, and 2. Well, I don't know if that's going to work. Well, we could try 1 and 6. Let's see if that works. So I could leave the x in, see what happens. Well, this is going to become negative x squared. This will become positive 6 down this column here. So, and then my middle will become 6x minus x, that's 5x. So I could do that. So I could do, one of my factors could be minus x plus 6, and then x plus 1. So I can do that for sure. But I could also go ahead and say, let's factor out this negative and do x squared minus 5x minus 6 to get that going. And check this out. I can just factor this as well too, and using the box method, x and x, I have to get negative 6. It's going to be the bigger number, and I'm going to get positive 1 here, and I'm going to get x minus 6, and I'm going to get x plus 1. It's kind of the same answer as I had before. I just have the negative factored out of the term that had of the linear factor that had the negative x plus 6 in there, right? So did that. That sounds good. Last example for this part. Now we're just gonna cook it and put everything together that that we've been working with so far. So I'm going to get negative 3x to the 4th minus 18 x cubed and minus 27 x squared. So with all that, what's going to happen is right away, before we do any steps, we should be on serious lookout for GCFs. So the smallest number of these is 3 and a negative as well. So I know 3 can be dividing each one. So I'm going to divide each one by negative 3. And then I'm going to check for how many x's I can take out. And it looks like x squared is what I can take out here. So x squared is what I'm going to take out there. And I'm going to get, well, if I take 3x squared out, I'm going to get x squared up front. Negative 18 divided by negative 3 is positive 6. X cubed divided by x squared is x. And negative 27 divided by negative 3 is positive 9. X squared divided by x squared is 1. Hey, so now I found a square in there. So I find something I can factor. Let's put it together. X, and it's either 9 and 1. Well, 9 and 1 add to 10, so that's not going to work. So 3 and 3. 3 plus 3 is 6. Hey, that works out. So my factors are going to be x plus 3, x plus 3. But it's repeating, right? It's the same multiplication. So what I essentially do have is 3x squared, x plus 3 squared. And that, my friends, is our factoring there. So you can take a look if you want to see the summary for factoring in the book. That's fine. I'm not too worried about it. We kind of got a whole big summary as we were going along, kind of been relaying that verbally. Last bit of business that I want to get across before we finish this video. Actually, we'll pause this video here, and then I'll make a part 2 that includes difference of squares. So end of part 1. I'll make a part 2 with difference of squares. Just a moment for us.